Okay, today is 7.1 and it's about rational functions. First thing you need to know, rational means can be written as a fraction. If you're a rational person, that has nothing to do with rational numbers. Okay, rational means I can show you the logic behind why you shouldn't touch that really hot pan or why you shouldn't pour water into hot oil. That makes you rational if I can explain that to you. But a rational function means can be written as a fraction. All right, if you just hear me say that right now, you'll remember 10% of that, which would probably be like, I don't know, 8 letters. So try to write this down. Rational means written as fraction. So then think about it. Of course, these are fraction functions. If rationals have to do with written as fraction, rational functions are fraction functions. The simplest of them all is the 1 over x function, which you have already done. Y equals 1 over x. It's this one right here. I would maybe have drawn it a little more like this. Do you remember that guy? They're all based on that, and then it's different permutations and combinations of that. All right, so I need to teach you all of these things. Horizontal asymptotes, vertical asymptotes. I need to teach you about holes in functions. And last, I need to teach you about slant asymptotes. That's something you wouldn't do in regular pre-calc. That's an extension kind of topic for honors pre-calc. Besides, what we're teaching you today in 1 day would be taught in 4 days in regular pre-calc. Okay, so this is an intense day. All right, I'm going to teach you not with the slides that are provided, but I have what I think is better stuff. So would you please add a page? You might need to add a couple pages right now into your notebook. And I'm going to give you an example of one that I think is a real good typical problem. All right. Do you get that this is the fraction function, which normally looks like this and has asymptotes accordingly at x equals 0 and y equals 0. In other words, it's got a horizontal asymptote and a vertical asymptote. But it's been moved. Where did that get moved? Left 3, and then how about that plus 4? Up 4. Okay, so I'm going left 3, and up 4. Up 4. And now my asymptotes are here and there. Move this over a smidge so they're not actually touching the asymptotes. There we go. Okay. Now, how do you determine, without having to draw the picture, what the asymptotes are? All right, this is important. The horizontal asymptotes are the ones that I'm going to make in blue here. Okay, the horizontal asymptotes are like the horizon. Okay, and Bob is the one who tells you about the horizontals. Okay, you get confused after a while. It's like, is that a horizontal or a vertical rule? Because there's rules for finding these things. Try to just remember one guy, Bob. Okay? Do you remember Bob functions are bigger on the bottom? And then there were some that were bigger on the top. And then there were some that were, you remember it? Same on both. Now, I know you learned this in honors higher algebra or regular higher algebra, wherever you were last year, or even in FST is another feeder class for this class. You learned these things. You may have forgotten them, but we got to get them back in your head here. The bigger on top kind are the kind where the degree is bigger on the top. This one's degree 1 on the bottom. Do you get it's kind of like there's an x to the 0 on top? It's degree 0 on top. Therefore, this one is bigger on the bottom. Do you get how this function has a bigger degree on the bottom? And therefore, it's a Bob. The rule for ones that are bigger on the bottom, Bobs, is that they're outsiders. Y equals whatever's on the outside of the fraction function. Do you get what's on the outside of the fraction function here is a 4. And therefore it's y equals 4. What if there hadn't been anything there on the outside? Well, then this wouldn't have been shifted up. And so then it would be back in its original spot, which is like 0. It's almost like there's a plus 0 on the outside, right? Couldn't I just say plus 0? So what's on the outside is a 0. So Bob is an outsider. Last year, you probably remembered it as Bob is a 0, but we didn't give you many examples where you'd put like a plus 4 on the outside. Okay, so in this equation, it's bigger on the bottom, and therefore we use the rule that it's whatever's on the outside of the fraction. Y equals 4. Here's another one where it's bigger on the bottom. 1 over x squared plus 7. If this is my original function, then Bob tells me the rules. Is this a Bob, first of all? Yeah, it's bigger on the bottom, and therefore it's the y is on the outside. What's on the outside? There's nothing out there, so I can say plus 0, right? So it's y equals 0. There is an asymptote at y equals 0. All right, what if it's bigger on the top? Like, for instance, you've been graphing this since, what? Okay, yes, you're right. You've been graphing these since you were in regular algebra. Y equals x plus 3. That's a nice simple graph. Okay, do you get that really there's a denominator of 1 if you want to put 1 there? Okay, so is it bigger on the bottom, bigger on top, or same on both? It's bigger on the top. So where are the asymptotes? There are no asymptotes. You hadn't learned any asymptotes back then because there aren't any. Okay, so if it's bigger on the top like this, then it's a bot, and there are none. I would like to say it's no bots, kind of like robots. Dumb way to remember it, but it works for me. If it's bot, there's no bots, no asymptotes. Okay, the last thing is same on both. My freshmen, I think it's time for you guys to head. I'm going to pause for a second while you are able to head down to that meeting you have. Okay, so sorry about the delay there. We had to get the freshmen off to a meeting. So now how about same on both? That's where you'd have something like this. Do you get how they're both degree 1? Degree 1 on top, degree 1 on the bottom. So then it's a ratio. Y equals a ratio. And it's a ratio of the lead coefficients. Let me just change this problem a little bit to make it more interesting. Otherwise, the lead coefficient is just going to be a 1 on the top and a 1 on the bottom. So maybe I'll make it like a 3 down here. Then this one's same on both because the degree is the 1 and degree is 1. Don't get all confused because it seems like it's bigger on the bottom because there's a 3 here. No, the degree is what we're talking about. Degree is same on both. So it's a ratio of the lead coefficients, which are 1 and 3. So y equals 1/3 for my example problem here. Those are all y equals things, which is like the horizon, which is like Bob. Bob tells us these. Those are all the horizontal asymptotes. All right, and if you look on my list, I'm showing the people in class the first slide over there on the other board. I see horizontal asymptotes, first thing on the list. I have shown you that. Now I'm going to practice it with you just real quick. Let's say we had this. Y equals x squared plus 3x all over 2 minus x squared. Is this one bigger on top, bigger on bottom, or same on both? It's the same on both. Why it's same on both? They all both have a degree 2. See, x squared, x squared. All right? No, you don't add. Some of you still, for some reason, think you add that 2 plus that 1 to make 3 on top. It's not degree 3 on top. It's degree 2 on top. Okay, so if it's same on both, what's the rule for SOBs? They make you sob because they're so hard. They're a ratio of the lead coefficient. So it's something over something. What's the top lead coefficient? 1. What's the bottom lead coefficient? -1, because there's like a 1 right there, right? And this 1 would negative goes with it. It would be -1. Final answer, the horizontal asymptote would be at y equals -1. Yes, the largest exponent becomes your lead term. So again, if I had this, make it minus 3x to the 5th all over 2x to the 5th. Would you agree that's the same on both? And as you were saying, all that really matters is this term right here, because it's the biggest one. And now I'd say, since it's a SOB, I use a ratio. Y equals ratio lead coefficients, which would be what? -3 over 2. Okay, so there'd be an asymptote at -1.5 or -3 over 2. Okay, so that one was one where it's same on both. How about if it's bigger on the top? Where's the asymptote on the bots? It's no bots. There's no asymptotes. No horizontals. Because it's bigger on top, and there's no bots. Okay, what if I make it bigger on the bottom? Let's say this is a 6. Now it's degree 6. It's bigger on the bottom. 0, because there's nothing outside the fraction. What if I move the whole thing up 6? Now the asymptote has to move up 6, right? So now it's y equals 6. Does that make sense to you? Okay, good. You get the horizontals down. Now how about the verticals? The vertical asymptotes. It's all about the base. I was saying this before Megan Trainor. Because in equations, people get all confused about whether it's the top or the bottom that sets these asymptotes. Here's a good example one. In this function, would you agree it's the same on both? If I multiplied them out, they would be both x squareds, right? So there is a y equals asymptote. That was from last. That was not a vertical. That was a horizontal one. Bob tells us that. And this is not a Bob, actually. It's the same on both. So it'd be y equals 1 over 1, because the lead coefficients would be 1 in both cases. So there's an asymptote at y equals 1. But that was for horizontals. For verticals, it's all about the base. Do you get that there are two important numbers here? 5 and -1. Then those things are either going to be asymptotes or they're going to be holes. Do you remember the rule, if you can factor it, you should? Has anybody been bothered by the top part because it could be factored? I hope that bothers you. If you see something like that, you're like, oh, x squared minus 1 can factor into x plus 1 and x minus 1. It's good to do that because then you'll notice things like this. That puts a hole in your function. If there's something on the top and something on the bottom, they're the same as each other, then that creates a hole in your graph. Your graph could be going along happily like this, and then at -1, which is like right here, let's say, it would have a hole in the function. Like it just wouldn't work in that one little spot on the whole graph. That's different than an asymptote. All right. So this one is a hole at what? X equals -1. And let's clarify, it's a hole at x equals -1. It's not a line. The other one's an asymptote. This guy right here, since there's nothing on top that cancels it out, it's just an asymptote at x equals 5. I think you all get, if you stick in a 5, you're going to have a problem because there'll be a 0 on the bottom. So that problem is either going to be an asymptote problem, it's going to be a hole problem. All right, so there's a hole at x equals -1, and there is an asymptote at x equals 5. This is a vertical asymptote. All right, so let's say you had this. I'd like you to tell me, what are the vertical asymptotes? What are the holes? And just a reminder of what we talked at the beginning, of the topic we talked about at the beginning, which was horizontal asymptotes. Ask Bob, if you would, what the horizontals are. And we've got almost everything down because I've talked to you about horizontals. Check mark on the board on the right. I've talked to you about verticals. I've talked to you about holes. The only thing I haven't shown you is slant asymptotes. We're not writing. Write down the answers for those 3 questions, please. I know you're paying attention, which is good, but I want you to write it out. Although we think our memory is good, writing improves it dramatically. Okay, Miss F. F, fearsome. Yes, I know. It's not really fearsome. But go ahead. Tell me what the verticals are. And did you factor this thing? What did you factor the top part to? Good. And now tell me about verticals, holes, and horizontals. Tell me about the verticals first. You are correct. That one is either got to be a hole or it's an asymptote, and it is an asymptote. Is it a horizontal or a vertical asymptote? So easy to get confused on those. It's a vertical asymptote because those are all about the base. Bob wasn't even a part of your decision here, right? Okay. So it was a vertical. And then how about the hole? X equals -3 creates a hole is correct. Good. -3 creates the hole. But just to clarify, a hole is a point. It's -3 comma something. Now, I know I didn't ask you to do this, but I need to show you the next level here. If the hole is at X is -3, there's also a spot where the graph is like missing a piece. You know, like right here at X is -3, there's this empty spot in the graph right there. Exactly where is it? At -3 comma what? What you do is you put in a -3 in the first place. You realize, oh, I'm going to have a problem because it creates this 0 on the bottom. But then once you cancel this out and you put in the -3 here, you can see exactly where y equals this whole thing, right? It'll tell us that y equals -3 minus 3, which makes -9, over -3 minus 7, which makes -10. -9 over -10 makes 9 over 10. So there's exactly where my hole would be. Yes? Oh, thank you. I was multiplying in my head. -6 over -10, which would make, when the negatives cancel, 6/10, which, yes, would reduce, but let's not get too detailed. It would be 3/5. Okay, so the point is that a hole is a spot. It's not just that X doesn't work there. It's also that there is a spot where it would have been if we had continued with the function. All right, and the last thing is the horizontals, which that's the Bob thing. Would you tell me, Miss W, the last part? Is it a Bob? Is it a sob? Is it a bot? What is it? It's a sob. It's the same on both because its degree on the top and the bottom is degree 2. So what do you think then? Y equals a ratio of the lead coefficients. If you had multiplied the top out, it would be 1x squared. If you had multiplied the bottom out, the biggest term would be 1x squared, 1 over 1, which is 1. You got it. Okay, so then what if you actually had to graph this thing? What if we actually had to graph it? Well, first thing you do is actually graph those asymptotes because they really do help. Once you know where the asymptotes are, you know the graph has to kind of follow that. Do you get there's an asymptote at x equals 7? And therefore at somewhere out there, there's an asymptote going like this. Okay. Do you get there's a horizontal at y equals 1? It's like right there. Do you get generally that these fraction functions look kind of like this? Okay. Last thing, there's a hole at -3 comma 6/10. That's way over here at -3 comma 6/10 would be like, there's a hole right there. So my function must go through that spot, except it doesn't touch that spot. So I just adjusted my graph a smidge. And now I could get a few more points just to tighten up my graph. Exactly where is it? I'd make an XY chart. And I'd put in some important points. Wouldn't the y-intercept be handy to know? The y-intercept is where x equals 0. Just stick in x equals 0 and figure out where it ends up crossing. Okay, and I'd end up with the original function, by the way, was x squared minus 9 over x plus 3 and x minus 7. If I stick in a 0, I get -9 over -21, which makes 9/21, which is a fraction and positive, and it's somewhere in that neighborhood. Yay. Except it's not a hole, it's a spot there, so I'm going to just put a dot there. Okay, so now I know that my function, and if you just check a few more spots, you'd find that the function must be here and up there. And that's how you graph them. All right, now the only thing I haven't told you is about how to find the domain. All right, I'm going to just remind you about, this is one of the first things we learned at the beginning of the year. The domain means what numbers work in this function. And I tried to tell you to always say all things work except. So everything works in this function except what? -3. The one I just drew you here. -3 is the one thing it can't be. So I like to do that with a number line and saying everything works except where's -3? Let's say -3 is here. It doesn't work there, but everywhere else it works. So you could make, here it is in number line notation. That was one of the 3 allowable forms. We also said sometimes interval notation, so then you'd say -infinity to -3 and -3 to 0, or to positive infinity. Or you could use the other form that was allowed is that step builder notation, x, where x is an element of the real numbers and x cannot be -3. What do you think's easier? I kind of like the number line. Okay, so let's talk domain on something a little more complicated. Let's say it's like this, x over x plus 5 times x minus 4. Do you get that everything works on my number line to start with, except what? -5 and +4. And the empty spot's there. Doesn't work there, doesn't work there. There we go. So domain on these is really easy. You just look for, it's all about the base again. Okay, now this is another important point. What if this had been like x plus 5 on the top? It changes things a little bit, but do you get I still can't allow -5 to work? The only thing that's more complicated is this isn't an asymptote anymore. It's a hull. But either way, it doesn't change the domain. Domain still can't allow -5, and it still can't allow +4. Domain would stay the same. So these things on the bottom are either holes or asymptotes. In this case, that would be a hole at x equals -5. And in this case, it would be a vertical asymptote at x equals 4. All right, I've taught you horizontals. Bob tells you those. I've taught you verticals. It's all about the base. I've taught you about the domain. The domain is all about the base again. It's pretty much just about the vertical asymptotes and holes. So these holes and vertical asymptotes together are what tells you your domain. And last but not least, slant asymptotes. All right. Yes? Nope. The range on these is everything except the horizontal asymptotes, but you don't have to worry about that for now. Okay. Last thought is slant asymptotes. If I had this, do you get it's just the parent function that's been moved 2 to the right? Okay. So here's my parent function. Parent function looks kind of like this, except I got to move it 2 to the right now. Does that follow the rules? The horizontal asymptotes are the ones that Bob tells you. Is this bigger on bottom, bigger on top, or same on both? This is bigger on bottom, it's a Bob, so it's y equals 0, because Bob's an outsider. Whatever's on the outside, there's nothing there, y equals 0. Do you get there is an asymptote at y equals 0 right there? Okay. How about the horizontal asymptotes? Does it follow that rule? Yes, it does. The vertical asymptotes are all about the base. Do you get there's an asymptote at x equals 2? That's a vertical asymptote. See, here it is. X equals 2. Getting a vertical asymptote. All right? There's no holes in this one because there's no like x minus 2 on top that would cancel the one on the bottom. That doesn't happen here, so there's no holes. And what's the domain? Domain's all about the base also. Everything works except 2. All right. So how could something have a slant asymptote? All right. What happens there is you have your asymptote that was running here ends up being slanted like this. And then this piece looks a little more slanty also. And it can't cross that asymptote line, right? So it goes like this. So how does that happen? That happens when you take the original one, and instead of a Bob being an outsider, Bob is still an outsider. It's just that now, instead of y equals 0 on the outside, a slant asymptote would come in if you had something like this. y equals like negative x plus 4. Now the slant asymptote would be, instead of y equals, Bob's an outsider, right? Now it's y equals that. So it's still a bigger on the bottom, right? In the fraction here, it's bigger on the bottom. So we go to the Bob rules. So what's Bob? Bob's an outsider. So instead of being outsider being just like a number, like 5, now it's y equals all that. So you have an asymptote at y equals negative x plus 4. It hits 4, and that has a slope of negative 1, so it goes like that. So now you have a slant asymptote. Instead of this asymptote used to be here, now it's there. Okay. You've learned a ton of stuff. Let's see if you actually have learned it. I'll give you some. Actually, instead of giving you more practice problems, let's start doing your homework together. Everybody flip down to the first of your homework problems right here. One, 3, and 5. Okay. That even says here, don't forget number 5. So I am assigning number 5 in this for you right now. So 1, 3, and 5, we're going to do 1 and part of 3 together. And then I'm also assigning 7 and 8 and 9. But you know what? Let's have you skip number 8. So far, we've only skipped one problem. Next page. I want you to do this problem. Now, some people are like, oh my gosh, it's got all these words in it in multiple parts, and it's the same exact thing. It's got asymptotes just like any other function. If you have to, just like simplify yourself down to, okay, here's my function, and I got to do a vertical asymptote. Verticals are the ones that are all about the base. So I look at here, and apparently 100 would be a bad thing. So everything works except 100, and the asymptote then must be at p is 100. Right, and then in the context of this problem then, okay, well, what is p? Oh, I guess it's about p% of the invasive species. Do you think you'd ever be able to remove 100% of this invasive species? See, does that make sense to you, that in the context of this question, p is a percentage, and then it makes some sense. You probably have this invasive species you're never going to totally get rid of. It's sad, but it's kind of true. Like, can you imagine buckthorn? Have you guys seen buckthorn? Super spooky plant. Do you think you'll ever get all of that out of our forests? No way. You could tear a bunch out, but you probably never going to get rid of all of it. And once certain kinds of fish get into your lake, actually what they have to do is kill off everything in the lake to be able to get rid of certain species. Like, they have to wipe the lake out completely, and then they start over again. And then just it's going to probably get back in there some other way anyway. So you don't usually like to wipe out an entire lake. I've seen them do it on a few lakes in Minnesota, but they don't do it on big ones like Minnetonka. Yes? Okay, fine. Of course, this is not actually a Pizzuti fish from Sasquatch Pond. I really doubt that it was. But anyway, the point is, all it is it's a fraction function again. Happens to have words around it. So all we're asking you to do is make this a real situation and use context. That's another thing you do a lot more of in honors. All right, and I think that even though these are really good and important and, you know, healthy problems for you, there's only so much you can do in one day. So I'm only assigning up to number 19. Okay, the only thing you could skip in that set was number 8. I also am on a second quarter more homework kick. I got to get a bunch of homework into the grade book. So if you have been skating on your homework, don't. You're going to pay a bigger price for it second quarter, because I know where we're going. If you stop doing your homework, you will really, really struggle on your tests. Okay, so I got to keep you doing your homework, so I got to keep putting it in the grade book. So get your homework done. It will be graded far more frequently than it has been for the past month, I would say. Okay, so let's go back to the problem and do one together here. Let's look at this first one, number 1. What's one of my favorite sayings that applies right there? You can factor it, you should. Okay, so let's factor that. 3 comes out. Now you have x over 3 times what? X minus 2. Okay, awesome. Now, the domain. It's all about the base. along with the verticals and the holes, that they're all come from this base down here. Okay, so the domain, I like to start your domain. I'm going to actually move this over on the board somewhere over, let's say here for now. I like to start my domains with everything working, like a number line where everything works. And then I'm going to remove the parts that don't work. Okay, what doesn't work? 2, because if I put in a 2, it crashes the function. So here's a 2, and I put an empty spot right there. And there we go. I've got my domain. Everything except 2. Now, I don't even care yet whether that's a hole or an asymptote. I will soon, but I just know it doesn't work, so therefore it's not part of my domain. Next, identify any verticals on this graph. Verticals. Which one of those? Are they all about the base thing, or are they the Bob thing? Verticals. Verticals all about the base. Yep. So verticals is all about this base, and that's this. And is it a hole or an asymptote? The only thing you got to ask yourself. Is this one a hole or an asymptote? This one's an asymptote, because there's no corresponding x minus 2 on the top to cancel out. So it's not a hole, therefore must be an asymptote. X equals 2 is the line for the asymptote. And by the way, since we're going to have to graph the function anyway, right now would be a good time to put in x equals 2, that line right there, asymptote line. Identify any holes in the graph. Did you notice nothing on the top and the bottom canceled? And therefore there are no holes in this graph. I'd say none. Next step, find the horizontal asymptote if it exists. Horizontal is bigger on bottom, bigger on top, same on both. They're the Bob things. Is this bigger on bottom, bigger on top, or same on both? Same on both. And therefore it's a ratio. Y equals a ratio of the lead coefficients. What's the lead coefficient on the top and on the bottom? 1/3, therefore. Y equals 1/3. So that's a line that's just above y equals 0. There we go, and I got my 2 asymptotes in there. Now, exactly where does this graph go? Well, it's really based on 1 over x, so it generally is going to look like that. If you want to get it more specific, you would have to graph it using a graphing utility, and I am okay with you just graphing this one by hand like I just did and saying, that's close enough. If you type this in a graphing calculator, by the way, you would just say a parenthesis around this part. So you wouldn't want to type x divided by 3x minus 6. Do you get your calculator? It'll do this part first, and that's not what you want. So when you're putting these in a calculator, which you don't have to do on this first problem, but please, you'd put this in like this. Remember, there are implied parentheses here that you need to put in to tell the calculator because it's not smart enough to know that. Okay? All right. Now let's move on to problem 2. Oh, the describing the behavior near the asymptotes, you're always would be saying the same thing. Do you know what it does near the asymptotes? Gets closer and closer to the asymptotes. Now, if you wanted to say it in terms of limits, there'd be a way to do that. I am not requiring you to do the assignment that way where you'd have to say it in limits. Would you agree that way off to the right here, I could say the limit as it goes to the right as x would approach 1/3? Sorry, x is approaching infinity. Here. Limit of the function as x approaches. This is how you do all limits. And then as it gets closer and closer to, let's see, the asymptote, which is at 1/3, x gets closer and closer to infinity, and the height of it gets closer and closer to 1/3. That's describing the behavior near the asymptotes, but I'm not making you write limits for today's assignment. Just in case you needed to know, though, that's how you could describe the behavior near the asymptotes. Now, we still haven't done inside limits. That's something I might teach you tomorrow, how to talk about. As I get closer to this asymptote in the middle, it's how to write an asymptote in the inside. Okay, Mr. B, would you, or Mr. O actually, would you please tell me how to start number 3? Okay, there you go. Bring up my favorite saying. And you can factor it, and so you probably should. So what do you get? I agree. And on top we have an x. Now, domain is everything except, so I like to start with a number line where everything's working except what? What are the two things that crash this function? Yep. So I'm going to erase little spots in here and there. Okay. Identify any vertical asymptotes of the graph. Verticals. That's all about the base on those. Okay, so here's my -4 and +3, and those are both asymptotes because neither one has a hole. To be a hole, there would have had to been something on top that was identical that would cancel, like an x - 3 on top or something. No hole, they're both asymptotes. X equals -4 and x equals +3. The two things that crash my function are asymptotes. Neither one's a hole. So holes in the graph, none. There would have to be something on the top that would cancel something on the bottom. And lastly is a horizontal. Bob tells you about the horizontals. They're the bobizontal. All right, so horizontal, Bob is bigger on bottom. It is bigger on bottom. What's the rule for bigger on bottoms? Outside. What's on the outside of the fraction? There's nothing out there, so we say y equals 0. Good. Graph the function using graphing utility. Okay, so I'm going to just put on my asymptotes. Here's x equals -4. To save you the time of having to make this on the calculator, x equals 3. I'll be your calculator. And there's a y equals 0 asymptote like this. And this is one of those moments where we have to admit to you that we lied to you. All this time we've been saying something to keep your life simpler. And now we've lied to you about something. Can anybody tell me what you know is going to be messed up here? Yes. Not the end behavior. Nope. Okay, let me challenge you with this. What's the y-intercept on this problem? You know how to find y-intercepts, right? X equals 0, right? And so what do you get? Yes. The y-intercept is, you put in a 0 and you get 0 over 0. But no, you don't get 0 over 0. You get 0 over 4 times negative. You get 0 over -12, which is 0. How can you have a dot right there? That's what it says the y-intercept is. It's on the top of an asymptote line. You actually can touch asymptote lines. We just never told you this before because till now you didn't need to know. And you're on a need-to-know basis. If we were in the military, they wouldn't just tell you all the country's secrets on your first day. You get to find them out later as you move up and become like a corporal or maybe you get to be a general. Now you get to find out there was an Area 51 and we do have an alien on ice and we can cross asymptote lines. Congratulations, you've made it that far. This graph ends up looking like this. You can cross an asymptote line. Now, you might think, why can you cross an asymptote line? Well, it just does. You can't stop it from crossing it because when you put in 0, you get 0. 0, 0 is a point. It's on the graph. Asymptotes that are horizontal asymptotes are more like guidelines that tell you where you're going to get closer and closer to. As opposed to vertical asymptotes, where if I stick in a -4, this function explodes. I got a 0 on the bottom, I can't get an answer, and therefore, that's different. Yes? Oh, I see what you're saying. You're thinking that it would go like this. Like this? All right. Tell me why you think that. Well, mine goes through the center. All right, I got an easy way to solve the debate. Would you agree that if I put in x equals -2, I will find out if the answer's up here or down here? And you might be right, because I haven't actually graphed this with the graphing calculator. Did you graph it with the graphing calculator, you little cheater? Okay, good. Then we'll find out if I put in a -2, who's right. Watch. -2 goes here, -2 goes here, and -2 goes here. And I get -2 over Positive 4 times negative 5 makes negative 20. Negative with a negative makes it positive. It is up here. And I was right, so leave me alone. These are hard enough to do without somebody in the back saying that you're doing it wrong. No, I'm good. I'm glad you asked me, but that shows you how I can check for sure whether or not it's any particular spot on the graph is right. Just stick a number in. The XY chart is your best friend on graphing. I've said that since the beginning. XY is your best friend in graphing. If I want the y-intercept, stick in x equals 0. If you want the y-intercept, stick in y equals 0 and solve it the other way. Okay, so I've done a couple with you. You covered a lot of topics. Got to cut the assignment down a fair amount. What I did assign, please get done. We are going to be grading more in the second quarter. More goes in the grade book as far as homework goes. All right, that's all the help I have for you for today.